Hi everyone, welcome to the lecture on sensation, the brain's source for information. These are our learning objectives for this lecture. We're going to continue to work on identifying and understanding the 8 senses, explore how the sensation is described within the OTPF. Specifically, we're looking at body structures, body functions, and performance skills. We're going to identify arousing and alerting versus discrimination and mapping functions, understand the concept of sensory integration, and explore the way sensation impacts occupational performance. I want you to kind of take a minute and close your eyes and think about a happy memory that you have from some point in your life. And I'm going to kind of give you a minute to really kind of immerse yourself in that memory and really try to picture it and re-experience it. As you're thinking about that memory, I want you to think about, what do you see? What's around you? Whether it's people or places, a particular setting, but what is it that's coming in through your visual system? What do you hear? Are there specific voices or sounds that are associated with this memory? What do you smell? They say that smell is one of the strongest senses associated with our memory. So is there any particular smell that's associated with this memory for you? What do you taste? Maybe there's something that you're eating or you recently ate or something like that. Is there any taste to this memory? What do you feel? What textures are under your hands or touching your skin in various places? How is your body positioned? Are you getting some feedback from specific joints because of the way that you're sitting or standing, or maybe there's some movement associated with this memory? Are there any internal sensations related to this memory? When we think about this type of experience and really key into our memories, it helps us see just how much our sensory system impacts everything that we experience. So it might have surprised you to see that today we consider that there are 8 senses to the body. We're maybe used to have learned about the first 5, vision, auditory, olfactory, gustatory, and tactile. But for OT, there's an additional 3 that are important: the vestibular, the proprioceptive, and the interoception system. And I know that we're going over each of these in our lab, so you'll learn a little bit more there, as well as through some of the other resources and materials that I've asked you to look at. There's a theory or concept about multisensory processing. And this is really looking at how information from the different sensory modalities is interpreted by the nervous system. And it also deals with how different sensory modalities interact with one another and alter each other's processing. So what this really is the recognition that while we can learn about each of those 8 sensory systems independently, they really don't function independently. They're very much happening at the same time and influencing each other. I'm going to have you pause the video here, and you're going to go and watch an ICE video, and it's a patient named Dr. T who's working on sit-to-stand transfers. I'll have some additional information of what to look for in his video, in the information in the reading assignment to kind of cue you to what I want you to look for. But it's a really good example of how our systems work together and how when one is impacted, other parts of us might not work as well. When we look at the sensory system, there's a variety of terminology that is used, and you don't need to memorize this. You've learned this all before, and as OTs, we just kind of need to have the basic understanding of how the sensory system works. If you were really involved in area of practice that was highly dependent on the sensory system, then you might need to learn more about these. But in the meantime, here are just some of the terminology and words that you would see as you're really delving into the nervous system. So we've got sensory reception, or the ability of us to detect sensory information with our central nervous system. Transduction, which is the process of changing stimulus energy into a coded action potential that then can be interpreted by the nervous system. So it's how whatever the stimulus is gets into our system. We've got receptive fields, which are a region of space on our body or within our organs in which the presence of a stimulus will alter neural firing. We've got adaptation rates, the rate at which afferent sensory receptors discharge into their afferent axon. So in other words, how quickly, how much stimulation is needed. We've got temporal summation. This is what occurs when a stimulus of limited strength is repeated in quick succession, such that the strength of the second stimulus is added to the strength of the first, and so on until the threshold is reached and the signal is sent forward. An example of that is that you might not notice at first if someone were tapping on your shoulder very lightly, but as they continue to tap, it gradually adds up and you begin to notice it. We've got spatial summation, which involves activating several receptors and summing the excitation from each to produce a response. So spatial meaning over a larger surface. So for example, we might not notice just one tiny finger touching our skin, but when that whole hand touches our skin, we notice it a bit more because it's all added together. The fiber diameter. This is the idea that the diameter of the fiber plays a role in determining how fast signals are transmitted and how quickly we're able to detect stimulation. We've got these ideas of habituation and sensitization. Habituation means that we have a decrease in neural response as a result of continued presentation of a stimulus. So for example, you might notice that the heat in your home or in a room, you hear it turn on, but then as it continues to have that low hum or noise, you begin to tune it out and you don't notice it as much. And then we have sensitization, which is a progressive increase in response to a stimulus with repeated exposure. So with sensitization, it might be that, at first something doesn't bother you, but then as it continues and increases, it gets to be a little bit more and more annoying. And so sometimes you might notice that maybe there's a particular noise that you find irritating and you may not bother you too much, but as it continues, it gets more irritating. Then we've got divergence and convergence. Divergence is when fibers from one source split and connect to many other regions. So for example, with our sensory system, we might have, our tactile system, input comes in and then it might go to several regions of the brain and activate different things. And then we have convergence, where input from multiple sources synapse together in one region. And so everything's kind of happening in one place. In Willard and Spackman, table 56.2 and 56.3 talks about how we can look at our sensory systems as either being arousing and alerting stimuli or discriminatory and mapping stimuli. Okay, so this is important for you to look at and kind of understand. The basic difference is that a stimulus that is an arousal and alerting stimulus, it makes us notice it. It kind of alerts our central nervous system that there might be a response needed from us, and particularly a protective response. So we can think about things like fire alarms, right? This is a highly alerting and arousing stimuli, makes us notice it because we might need to respond to it. Compare that to discriminatory and mapping stimuli. These are the types of input that's coming into our system that enable us to gather information that supports and generates our functional behaviors. And it helps us understand the spatial and temporal qualities of what's going on in our body and what's going on in the environment in order to help organize the nervous system. And so sometimes it can be the same stimuli. So at first a stimuli might be arousing and alerting, and then we respond, we realize that, okay, I don't really need to have a protective response to that, but it helps me understand what's happening in my environment. And so then it can translate into more of a discriminatory and mapping. We as therapists can use these concepts. So if we have someone who tends to be not as in tune with their environment, someone who it takes a lot of stimulation for us to get their attention, then we can present some stimuli that really try to get them to arouse and alert a bit more. So we might use stronger sounds, stronger actions, things like that. So this is the concept that we're using when we're taking someone, for example, who tends to have low arousal, low responses, and maybe we have them do things like do jumping jacks before we try to do some learning activities to kind of get their system more aroused and alert. Then we might also use our discriminatory and mapping stimuli. So if we have someone who's kind of overly aroused and stimulated, this is like someone who maybe is hyperactive, then we can use kind of softer and more subtle stimuli in the environment to kind of help tone that down a little bit and maybe help them focus in on just what's happening around them, kind of quiet down some of those other things. Okay? But take a look at that table and kind of read that over. Now, we haven't at all started talking about theory yet. We're going to do that next week, but this chapter, and as we start to look at some of these different areas of our body functions, we start to get into theory a little bit. And specifically, this one looks at Jane Eyre's sensory integration theory, which some of you may have heard of before. Jane Eyre is an occupational therapist who really captured and published what is happening in the human body with the sensory system. And so she talks about sensory discrimination and sensory responsiveness. So sensory discrimination is the information processing from one or more sensory channels that allows us to rapidly and accurately know the position of the body, our relative distance to other people, details about our body, what's on our body, and details about the surrounding environment. Okay, so we have to be able to discriminate and sense everything that's coming into us so that we know where we are and what's happening around us. Sensory responsiveness is the concept that the way in which an individual manages the intensity of changing sensory conditions from the body and the environment. And each of us has unique thresholds for sensations or combinations of sensations that we're going to experience as either pleasurable, neutral, or aversive. So when you think about sensory responsiveness, we can think about the fact that what is happening in the environment, I might notice and feel like this is kind of a pleasurable or even a neutral stimulus, might be really aversive to someone else if they're highly sensitive to whatever that stimulus is. So some of us are more responsive to sound, some of us to motion or movement. And so it's again that concept that there's different levels of typical that we experience. One of the ways that you can look at how things might be different for different people is this video in my language, which is an adult who has autism, and she kind of displays and then discusses how she experiences the world in a sensory way. So I'm going to have you pause, and I'll put the link to this YouTube video in the Canvas reading page. So pause here and go look at that and then come back. Now that you looked at that video, it's kind of interesting, isn't it? It's a different way to think about how people experience the sensory world. And it's very interesting how she talks about that, you know, we're kind of saying that she is atypical, but maybe it's really us who's atypical because we're not experiencing the sensory world as deeply as she is. Some additional constructs of Jane Eyre's sensory integration theory. Sensory modulation is our ability to regulate and organize reactions to sensory input in a graded and adaptive manner. The balancing of excitatory and inhibitory inputs and adapting to environmental changes. So in other words, we have to be able to kind of regulate and organize everything that's coming into us. If we responded to every single sensation that's coming at us, we would be overwhelmed because there's just so much coming in. So we have to be able to kind of almost tune our channels and tune some things up and tune other things down so that we don't get overwhelmed and we can focus on the things that are most important. So even, for example, as you're listening to this lecture, you're having to kind of tune up your auditory sense to focus in just on the sound of my voice, and maybe there might be some sounds in the background that you're tuning down so that they're not as distracting to you. Okay? Self-regulation, that's our ability to alter our behavior to match the environmental demand, to take in, integrate, and process sensation and use it as a foundation for appropriate environmental interaction. So the ability to really kind of gauge how I respond to things. So in other words, something that's irritating to me doesn't cause me to suddenly, start yelling or kind of have a meltdown. But we see that. Sometimes we see that in children just as they're developing, typically that they don't have those same self-regulation abilities, that when they get overly stimulated, they sometimes can't control their behavior as well. And praxis, that's our ability to conceptualize, plan, and execute skilled tasks, and it's a goal-directed motor action supported through the processing of sensation. We'll look more at praxis again when we turn to look at motor functions, but really it's the idea that sensation and everything we're experiencing in the world through our senses then dictates how we respond motorically. So an example of this is if you think about a water bottle, right? A water bottle can be in multiple different forms. We can have kind of a soft plastic water bottle. We can have maybe a more hard a water bottle that's still plastic and it's maybe about the same diameter as that smaller bottle, and then maybe think about one of the little bit wider stainless steel water bottles that someone might have. Each of those, as I look at that water bottle, I take in visually, as well as my previous experience with my tactile system, what that water bottle is going to feel like, how wide is also my proprioceptive and kinesthetic senses are supported in that. So I can look at that bottle and anticipate how wide I have to spread my hand as I reach for that bottle, how hard I need to close my hand around that bottle in order to lift it. That soft plastic bottle, I can't put as much force on, or the water's going to shoot out the top of the bottle. However, that heavier stainless steel bottle, I need to have a little bit more force because the bottle's going to be heavier, and plus there's not going to be any give in it, and so I can use a little bit more of a firm grip in order to lift it. So that's praxis. That's our ability to kind of take in everything and put it all together and respond appropriately. This is just a chart from the Willard and Spackman book that kind of summarizes sensory integration and shows us how it's these the senses are the base of it, and then we, through interpreting everything that's going on, that's how we end up with some of our end products that are really related to our cognitive abilities, our ability to concentrate, organize, how we feel about ourselves. So it's really showing that all of these different concepts are connected. And you can look at this chart and see that a lot of these are what we are calling our body functions, right? We've got our sensory on the left. In the middle, we have then some of that begins to be our motor skills and our cognitive skills, and the end product is really some of those higher level cognitive skills and emotional regulation skills. And that concludes our discussion on sensory.